Okay, so we're gonna start talking about. So we've seen self floating around everywhere in these in the classes that we've been making. We haven't talked a lot about what self is, and maybe are there cases where you wouldn't use self. So we'll look at different kinds of variables that you can have in classes. There's class variables and instance variables. We'll talk about that, and then we'll also talk about instance methods. So you can have different kinds of methods, instance methods and static methods. And then because using a static method in a class involves a decorator, we'll talk about decorators. So that's what we're gonna be doing today. So I'm gonna get this open. All right, so we've been kind of faithfully using this book thing. So as an example, so we'll continue doing that. So the idea is you have an application, and your application is for a bookstore. So you need a way to represent books in your application. So rather than creating just a whole bunch of objects or something to represent books and starting from scratch every time, you create this template, which is a class. So can someone help me write a book class?
Start with class.
Okay, so I need a class keyword.
A class book.
Right, and that should be capitalized. So we have class and then the name of the class and then a colon, and then technically we could just do this, and that's all we need to make a class. But we don't just want to do that. So how do I tell this book class the kinds of information that I want in each individual instance that might vary from one instance to another?
Start with the def key, def.
Okay. And what am I writing here? So what is this first method that we write going to be?
Oh, I'm sorry.
I'll go ahead.
No, you can go ahead. Go for it.
The double init or double under init.
Okay, so this init method. So can you tell me about this dunder init?
Yeah, it's like the properties from like a values perspective that the class could have or have assigned to it, I guess.
Right? Yeah, so yes. So oftentimes we will put the specific properties that we want an instance to have here. But we're actually not restricted just to that. So we'll see this in a second. So basically init, you can think of it as the first thing that runs when you, that's technically not true, but you can think of it as the first thing that runs when you create an instance. So any kind of setup that you want to do for an instance, you put that stuff in this init method. So init, what's the first parameter that init takes?
Self.
Yeah, and Anthony, can you tell me about what is self? What is the self?
I have no idea how to describe it. It's just required, and it's gonna be there all the time.
Okay, I mean that's fine as like a rule of thumb when you're learning this stuff. It's just remember that you have to have it basically all the time.
So it's like a means of the class to refer to the specific instance of that class?
Yeah, exactly. So kind of you could think of this as like a generic, like I don't know what this is going to be yet, but it's a generic way of referring to a given instance that will be created. So we have self, and again, this self, the language itself, Python does not stipulate that you call this self, but there's a strong convention that you do so. So we'll call it self, and then the other parameters is basically stuff I want to set up my object with, to my book object. So we'll have title. We'll just go with title, and that'll be good for now. So we have title, and then how do I make sure that an instance has a title or has access to the title?
Gonna go self.title equals title, or whatever you want to name it.
Okay. You can do this. And just to again, this is like the most common thing you'll see is like these will all have the same name, like title, title, title. So it might be confusing, like what the hell's going on. So you can call this so this is just the generic name for the parameter that you're passing in, and this is actually how you'll refer to it in a given instance. Okay, so I think we have enough to start creating books now. So how do I create an instance of a book?
You can do like book, like book equals,
Okay,
well, equals the, or book one equals,
okay,
maybe book one equals book in uppercase letters.
okay,
Starting with, and then parentheses, and then the book name, book
Okay.
title.
okay. Not very creative, but so how do I, if I wanted to print book one's title, how would I do that now?
Just go print parentheses book one dot title,
Okay,
or you can build another method in there to print it, I guess, as well as the other option.
yes. Yes. So this works. So now we've created an individual book object. Okay, so that's good. And we could also create a an instance method. Well, before you go into methods, so I now have this class book, and I can create instances of book, which are kind of referred to by this self parameter here. And then any instance of a book that I create will have a title. But book itself doesn't really know anything. So if I try printing something like book.title, I get an attribute error. So the class doesn't have an attribute. So I have an instance attribute here, but I don't have a class attribute. So what if I wanted to create a class attribute? So let's talk about why you might want to do that, for example. In general, a class attribute is going to be something that you want to be the same for every instance. So we create this instance variable called title, and we're kind of assuming that every instance we create will have a different title, right? So titles are supposed to be kind of unique, or let's just say unique to every instance. But there might be a piece of information that I want to be the same for every instance of a book. So for example, maybe I want to keep track of the inventory or something. So I want to know how many books I have in total. And I want every book to know how many books there are. So I could create a class variable, and I could call it inventory count. So some people will make this all caps, which I would probably do as well, but it doesn't really matter. So we have this class variable, and notice that it's not inside of a method. So when you create an instance property or an instance variable, it has to happen. We have to create it inside of a method. Here, when we create a class variable, we create it outside of any method. So this actually belongs to the class. So now if I try to print inventory count, I get 0. So book still doesn't know anything about title. The class doesn't know anything about title. So this is not a class attribute. This is an instance attribute, but inventory count is a class attribute. Are there any questions so far?
Does that show up then when you do a dir on it? Do those variables show up in the
On book?
Yeah.
The inventory count should. I don't think that title will. But if we do dir on an instance,
Oh, okay. Yep.
inventory, and if we do so we can you can also access this value from an instance. So you could do book one dot inventory count. So that also works. Okay, so now I have this inventory count, and so I mentioned earlier that this isn't just for properties. So this init function will run when the instance is initialized or created. So I can do anything else. This is just a function, so I can do anything in here. So one thing I could do is increment inventory count by 1. So anytime I create an instance of a book, my inventory count will go up by 1. So I can do book dot inventory count plus equals 1. And I'll create another instance. And just for thoroughness, let's create a third. Okay, so I can create all these books, no errors. And let's try printing book.inventory count. and that is 3. So if there's a piece of information, oftentimes you may not necessarily want to do this, not an entirely realistic example, but sometimes there's like constants or just anything that you want an entire class to have access to, you can create a class variable for. Okay. So let's make some more methods. Sorry. So I'm going to add another variable here. I'll add price. Oops. And we'll just add this here. Okay. So we've just added another instance property here. So price, we create a book. Now we have a title and a price. And we could do the same thing here. We could have something like, I don't know, total value. And you do the same thing here. You could do book dot total value plus equals dot price. And then let's print out the price, total value. And we get everything added together. All right. So let's look at creating an instance method. So let's create an instance method that will just return, or let's just say that it will print basic information about the book. So how do I create an instance method?
Start with def and then the name of the method.
Okay. So let's call it display. What should I put here?
Self.
Yes. So that's a good just reflex to do initially. So self, and we will, let's print, I'll print a formatted string. All right. So if I want to print out, let's say book, or let's say book 3 dot display, you can call that, and I get this printed out. Are there any questions about that? So what happens if I don't include self here? Oh, it's not going to work. So it says it takes, let's see, it takes 0 positional arguments, but 1 was given. Can someone explain that error? So where is this error occurring first off?
when it's being run, it's automatically putting self into the display method, even though display isn't asking for an argument.
Yeah. So before we, so yes, that's good. But I want to talk about how we can read an error message here. So where in my code is this error occurring?
Under the traceback line where it says file and then the name of the path of the file, right next to that it says line 24.
Okay, good. So I know what file this is occurring in. We've only been working with one file at a time, so that may not be important to you, but shortly that will be important to you, knowing which file this is occurring in. So it tells me the file, which is book.py at line 24. So now, error messages, no one likes getting error messages, but they're very helpful. Sometimes more so than others, but so I know exactly where this error is occurring. So I can focus my attention here. And then it's telling me basically what didn't work. It's book3.display. Then the kind of error that I'm getting. So that can also be useful. I'm getting a type error. And then the message is display takes 0 positional arguments. And it's saying that because where I define it, I've defined it to not take any arguments. So display takes 0 positional arguments, but 1 was given. So yeah, Jess is right. So it seems strange because I've defined it to take 0 arguments and I call it with 0 arguments. So that's the way it should be. But the problem is that this is by default, Python will treat all of your methods in a class as instance methods. And by default, Python will throw self in as the first, throw the instance in as the first parameter of an instance method. So Python is actually calling this method with self. So that's why you get this strange error telling you that you called this with a method when you actually didn't. So we'll put this back in here.
And just to tack one thing on there, if you scroll down, Chad.
Yeah.
If self is still confusing you, 24 line 24, because book 3 is what self is becoming. So it's as if book 3 passed itself into that call for you. So yeah.
Something like
it, even though book 3 is the one calling the method, or you're calling the method on, book 3 is like saying, hey, I'm going to send myself in as the argument so that it will be self. I will be referring to myself for anything that I try to do. Hopefully that helps draw a better picture, maybe.
Yeah, it's definitely weird. But yeah, this is, as Chris said, this is what Python is actually doing. But it's just a little bit easier maybe to write it like this. Okay, so now we can display this book, and that's good. We have an instance method. Let's see. So it's not always the case. So 90% of the time, your methods are going to be instance methods, and 90% of the time, your variables are going to be instance variables. But there are cases where you don't need to operate on anything that the instance or the class owns. So that might sound a little abstract, but sometimes you just need like a little helper function, maybe to do some math or something like that. And you don't actually need to bring in the class. So you can tell Python that, hey, This is just the helper method. I don't need to access anything in the instance. So let's see an example of that real quick. So let's say that we have a price here, but we want a method that will convert, let's say this is US dollars, to convert our price into euros or some other currency. I know nothing about currencies or conversions, so this is just going to be made up. But so let's write a method that converts the price to euros. So first we'll write def, and then we'll write convert to euros. And well, let's leave this blank for now and see if we need to use self anywhere in this function. So we could do some logic here. So we could do something like return self.price times 0.83 or something like that, right? And that could give us our imaginary conversion to euros. But what if the conversion logic was a little bit more complicated? So we might want to write a helper function so we can put that logic in that helper function. So let's see what that would look like. So def complicated okay. So I'll just include self for now. So self. And then instead of returning this, I'm going to return the call to and let's see, what should we pass in? Self.price. And I can just, I'll just make up some stuff here. So equals price times 0.93, and then add tax, I don't know, base plus base times 0.4, and then return add tax. So if I try to run this right now, let's just walk through it real quick. So I have convert to euros. So when I call convert to euros, I call this other helper function that I have, and I pass in the price of this book instance that I have. Then I do whatever calculated complex calculations I have, and then I return a value. So let's see if that works. So print book one dot convert to euros. And it looks like this works. So what did I, 23, 22 something. Okay, so yeah. So that works. But where am I using self in this helper function? So I'm not using self in this helper function. So let's just get rid of self then, right? I'll just get rid of self. And I'll run this. And now we have a problem. type error, complicated calculation takes one positional argument. Right, so we've defined it here, and we've said that it takes one positional argument, but two were given, and we called it right here. We only passed in one. So what's happening? Well, the same thing, right? Python is implicitly passing in the instance as the first argument. So we could leave this here, and that's fine. Our code will work, but from a coding perspective, maybe this is not as precise as we could be. So what we want to do is tell Python, hey, don't pass in self. I don't need self. And Python has a built-in way of doing that, and that is there's a decorator. So a decorator is a general term, and we'll look at what a decorator actually is in a second. But the syntax for that is you go to the line above the function that you want decorated, i.e. modified slightly, and we'll do the @ sign and then static method. So this looks pretty strange, but when we decorate a method in our class with static method, we're telling Python we don't need self. So we can treat this as just, it's basically like this function is independent of the class. I think some people actually don't like using a static method because you could just write the function somewhere else and then import the function and use it. So you don't, in some ways it's not like attached to the class. Okay, so we have set, so let's try running this and seeing if that works. Okay, and that does work. If we try passing in self here, now we get a slightly different error. Now we're missing a parameter, right? Because Python is not including this. It's not including the instance automatically. So long story short, if you find yourself writing a function, especially like a helper function that doesn't require access to self, then you can decorate it with a static method.
Chad, is there a reference for all these decorators?
Yeah, I'm sure that there's one place. Let me just do. Real Python is a good reference. So this would be a good reference to take a look at. So decorators in general, that's just a general thing. And the way that the syntax in Python is this @ sign. But decorators are basically just higher order functions. They're functions that take in a function and then return something. So let me think. I don't know if we should talk about decorators right now or keep going with this inventory. Let's keep going here, and we'll just introduce one other, a couple other things. So here we're overriding this built-in init function. We also have this display, right? So we have so if we want kind of to print some kind of representation of what our instance is, we have this display method, and then we do that. But Python also has an API that's designed to do something similar. So there's a way to override the string representation of a given instance. So first off, let me try just printing book 1. And I get this. This is the default way Python tells me what this is, this book object, or an instance of book, the book class. Okay, but this may not be the most helpful representation. So we can actually customize. We can tell Python what to do when we just call print and pass the object itself. So we're going to override this, and this is the str method. I'm going to pass in self, as we almost always do. And then all we have to do is just return whatever we want. So I'm just going to copy that code, except I'm going to make it return rather than just printing. And then when I call print on an instance, instead of getting this, this, which may not be as helpful, I can get my own custom representation that's useful to me.
Question.
Yeah.
I know you can't do this in JavaScript, but in Python, can you return multiple lines?
Return, if you add like I mean, you can only return one thing, but you can make that thing a complex thing. So like if you had a really long string, for example, is that what you're asking?
Or say I wanted price to be on a second line.
Oh, okay. So yeah, there's a couple of things you could do. There's if you use triple quotes, it will take your formatting. I think I have to do this to make it.
You can actually use the encoded character, the /n. It will, if it's printing to the console, you can use the special /n character.
Yeah. So there's a couple ways to do it. One is you can use triple quotes, and it's kind of like a format string where it will, so if I tab this over, it will tab it over when I print it, so it keeps the formatting. You can also, as Chris said, let's go back to this, just add a new line, so the escape and I have an extra space, but there we go. And if you want to add 2 new lines, maybe and tab, you could do that. All right. So what happens if I delete a book? Speaking of this. So let's try, we'll delete book 1, and then let's print book.inventory count. So that is wrong. I just want to talk about it's kind of like a life cycle with objects. So they get created, and there's certain methods you can hook into when it's being created, like init is one of them. Also, when it's being destroyed, it will also call these like thunder methods under the hood. So you can hook into those and you can add customized behavior. So there's one called del. And actually this could be doesn't need a self. So we're going to tell Python that we don't need self here. And we can do book dot inventory count minus equals 1. So if we delete, or if this object gets garbage collected, then we can decrement our inventory count so it stays accurate. So let's run this again. And now we get 2. So we start off with 3, then we delete 1, and then our inventory, our class variable, this inventory count gets decremented. Okay. Are there any questions about that? So we'll talk about decorators in a sec. Are there any questions about static method versus instance method, or class
Chad,
variable versus instance variable? Yeah.
what was the syntax for deleting that again? Did you just hit del and then the name of what you're, okay.
Yeah.
Thanks.
All right, let's talk about decorators. So decorators, it's weird at first. Higher order functions are always a little tricky conceptually, just because it's kind of complicated. But the short of it is that a decorator is a function that takes in a function and returns a function. So why would you ever want to do that? There's a couple reasons you might want to do that. One of them is you might want to tweak the behavior a little bit. So for example, if the default behavior is to include self as the first parameter, you might want to add a decorator, like a modifier that stops that behavior. So you don't really want to change necessarily the function itself. You just want to tweak it a little bit. So rather than having to write a completely new thing. So there are some use cases where this could come in handy. So let's say, for example, that I want to write, I want to be able to log all of the arguments that my functions are getting. So I have a whole bunch of functions in my application, and let's say 10 of them I want to log all the arguments when they get called. So there are a few ways you could go about doing this. You could add maybe like print statements, or you could write another function and then call that function inside in the first line. So let's try doing that real quick. So I'll just write an add. All right, so I call this function and I get 3. Not a surprise, right? And let's say I have like 10 other functions and I want to do the same thing, right? So if I want to log the parameters that this gets called with, I could just do print A and B, right? And that will work. I can see it was called as 1 and 2. But then I have to add this to every function. I'm kind of like changing the function, which may not be a good idea. And maybe this is a very simple example. Maybe there's slightly more complicated things that I want to do. It just could end up being a mess. So it's not really a clean way of handling it. You don't want to just have to go through one at a time and make these modifications. So one thing you can do if you wanted to log all the arguments is write a higher order function or a decorator. And let's do that. Def, call it log args. And this function will take in a function. Ultimately, in this case, we want it to take an add. This is going to take in a function. I'm just, by the way, consider this talk on decorators just exposure. So you don't feel like you need to memorize it or understand everything right now. This is just the first exposure. So log args will take in a function, and it's going to return a function as well. So we don't really care what this is called. We'll call it inner. And if we want to make this as flexible as possible, if we know that there's only going to be one argument, then we can just have that, write that here, but we can make this a little more flexible. We could also pass in keyword arguments as well, but we'll just keep it like this. So this is basically, it's basically like destructuring in JavaScript. So this allows us to get all of the arguments, any number of arguments, whether you pass in 1 or 10, this will allow you to get in all of them. So you don't have to know in advance how many arguments this function is getting called with, which is nice. Okay. And then what I want to do here is log all of the arguments. So I'm going to log all the arguments. And then I don't really want to change the behavior of the function that I'm passing in this case, add. So I'm going to run that function. We'll talk about this in a second. Does this make, can someone explain to me what the hell log args is doing now that we've written it out?
I'm not sure about that very last return,
Sure.
but it's taking in whatever function you're putting in, and then kind of separately, it will be creating a new function called inner, which takes arguments, prints those arguments, and then returns the function that you brought into it. I don't see anywhere that inner's being called, and I'm not sure where args is coming from because it doesn't match. Well, does it match the function somehow?
Yeah, so there's definitely some strange things. So I mean, is inner at any point getting called? Or would it be? Is it getting called within log args?
No.
Yeah, that's right. It's not getting called. It's just getting returned. So log args takes in a function and it returns a function as well.
So in that last, on line 5, that return, is that just kind of implicitly returning the function as a whole?
It's returning inner.
I think that's going to return none. Usually you would return inner, but not called. We'll try. Oh, I guess.
Sorry. Yes. Yeah. My bad. I forgot.
Yeah, I think Jess was getting really confused because you weren't doing that, and
Sorry.
so she wasn't following the last bit of it.
Sorry.
That was Python.
Yeah, that was a mistake. Sorry. Yes. Yeah. So I'm returning inner. My apologies. Didn't mean to make this even more confusing. So yes, we are returning the inner function here. So if I want to wrap add, if I want to wrap this, so I won't even print this now. So I want to call add, but I want it to run through log args because I want to see what parameters it was called with.
I'm guessing you put the at symbol log args and then call it on the next line below.
Okay.
Or-
Yes. Right. So we could do that. So that's a nice syntactic sugar that Python gives us. But what if we don't? What if we don't know about the decorator syntax? Can we still use log args?
Could call log args directly and pass in the add function,
Okay. Log args add.
but I don't know if any where you would get the arguments from, so I don't know.
So
Do you
that's a
put
good,
the
good
arguments in there
question.
with it?
You could try doing this. Let's see if that works. So I don't think that worked because we didn't.
Try printing it.
But log args should print
Yeah.
itself, right?
So this would
Oh
run.
yeah.
So we have a couple options here. So let's think about what's happening. So we're calling log args and we're passing in a function. Log args returns a function. So this should be equal to a function right now. So let's check that out. We'll just call it so it is a function. So how do you call a function?
You would put the arguments in parentheses afterwards.
Yeah, so let's try that. But what arguments?
I think you put in 1 and 2.
Any other thoughts? But isn't it add that takes in 1 and 2?
Log args will return add, a modified version of add.
Mm-hmm. Exactly. So now this works and we get the, right? So another way of writing this, let me just write this in, an alternative. I'll leave this, that's fine. So another thing we could do is call log args add 1 and 2. And that'll do the same thing. So the reason, we won't talk about it here, but the reason this works is because of something called closures. So this value, this function, this inner function knows about it, even though we've called it and it's already returned. So you might think that this value should disappear, but it doesn't because of something called closure. We can talk more about closures later, but that's the basic mechanism that allows this to happen. So we have this function, it's a higher order function. It takes in a function and it returns a function. And within this returned function, this is where the arguments for add come in. So it's like we're getting them separately. We're getting the function first, and then we're getting the args. So an alternative way of writing this, like a nice syntactic, syntactic sugar, a nice concise way of writing this is to use the decorator syntax. So I can call log args decorate add, and now every time I call add, it's automatically going to do that. And note that I haven't had to modify my add function at all. So my add function is just like it was before. So I'm not adding print statements or anything like that. So if we look back at this example, the static method, we can see that this static method, all it is a function that takes in another function, and it's in this case it's just removing one of the parameters basically. So it's slightly modifying how the function works. So the questions about that, this is something that will take, if you don't get it immediately, that's perfectly normal. Something that will take a few. It took me many passes. So
Is there a way to kind of go backwards, and besides just deleting line 7, can you ever get that add function back kind of like in a more clean or pure state?
Like, could I call add and somehow not have the decorator?
Right.
I have never thought of that before. There might be some way, but I don't think there's any obvious way of, like, let's say this one time I call add, I don't want to call the decorator.
You pretty much think of it as permanent then.
Yeah. There might be a way to do it. Yeah, Chris, if you know.
No, I actually have never tried to retrieve it after the fact, but you probably could if you wanted to like investigate that, you could introspect the object. So you could just do like print dir of add and see what properties it has on it. And a function is really based off of a class. It has attributes. It's just like any other object you work with. So it has attributes that you can probably talk to. There might be some like meta information it stores in there back to the function that it's eventually going to call. So you might be able to do
maybe annotations.
It might be hidden in one of those things in there. Closure, maybe. Closure might have some kind of.
Let me just see. Add.
This is getting into the weeds, but this is basically how I would find it.
So closure. Let's try closure.
Yeah, closure might be storing the value, the reference to that function, maybe. Yeah, there it is. It's right there. So if you went through the object add and you said dunder closure, and then you did dot, what is that, a tuple? Yeah, so you index the first item and then you called 1, 2 on it. That might be the original add method. It's a really crazy way to try to get to the original add method, but it might work. Cell. Oh yeah, I don't know what that is. Yeah, I've never actually done this before, so this is kind of how I would like try to if that was what I was trying to do, I'm like, I want to get that pure function back out. The pure function is stored somewhere. It has to be. It's somewhere in memory, and then you just have to find that reference. And so whatever cell at thing is, you could get to it that way. But doing what Chad just did, this is how I inspect objects and find my way to my own answers. If I just can't find it on Stack Overflow or something, then I just start. This is exactly what I do. Like if you can learn how to use the dir function and inspect objects in your code, you'll start learning more about the data types and values a lot faster. This is invaluable. Like this tool right here, just to be able to do this is really invaluable.
Yeah,
companies look for this. Like if you can do this, you're doing good.
Yeah, Python is, I guess, famous, or one of the good points in Python is its introspection abilities.
So then
Okay.
maybe the advantage of using a decorator would be to be able to like to add log args to a bunch of functions without
Yeah.
having to rewrite it over again.
Exactly.
In the future, when you get to web frameworks, one popular use of a decorator is called login required. So you can actually protect one of your views and say, you can protect another view function with a decorator called login required. And basically that function runs first and it says, hey, do I have all the necessary pieces before I run this view function? I want to kick this person out of here as soon as possible. But if whatever logic I have is there, if they meet all the requirements to be login required, right? If they have all the details I need, then yeah, I'll call that view function that I'm protecting basically. So that's the real cases that you'll use for it. There's also loggers that use it too, kind of like the simple example right here where it's printing args. You can use it to trace function calls and stuff, but yeah, that's it. That's all I'll say. It's really useful.
Yeah, it's useful, and it's the way the syntax that Python uses for it is also, it makes it really easy to use. So if this is still kind of boggling your mind, that's fine. We'll see it some more. But just in terms of using, so the overall point for today is we have class attributes and instance attributes. A class attribute belongs to the class itself, and individual instances can access it and even change it. We didn't show that, but it belongs to the class, whereas instance attributes only belong to that given instance, and the class doesn't know anything about them. And then in terms of methods, we have our standard instance method, and they're instance methods because they all get an instance, right? An instance is the first parameter. If for whatever reason you don't need an instance, then you can use the static method decorator. And that basically tells you or whoever's looking at your code that this is kind of like usually a helper function or something that maybe does some IO or something like that, some other side operation. All right. Let me stop recording.